I think this one is a very important question.
Do you want to live forever? Jeff Bezos might think so.
Hell yes.
In 2021, Jeff invested in a biotech company, Altos Lab, aiming to achieve anti-aging and longevity through cellular rejuvenation therapy. For millenniums, humans have been pursuing longevity or even immortality. Yet, no one in history has successfully achieved eternal life. And why is that? One major factor in determining people's life expectancy is telomeres. The end part of the chromosomes are telomeres, which determine the number of times our cells can divide. We can use a book as an analogy to quickly understand these concepts. We may think of a chromosome as a book, and every page with words is like a section of genetic code. All these pages together are our DNA. We have 23 pairs of such books in our bodies. Each pair are two identical books, with one exception. Men have 22 pairs of identical books and a pair of non-identical books. This non-identical pair is the gender pair for men, containing X and Y chromosomes. While for women, this gender pair is the X and X chromosomes. So every person has 23 pairs of such books in the cells. The contents of the books are the person's genetic information. In these books, the first few and the last few pages are blank. These blank pages are telomeres. When a cell divides, it copies these 23 pairs of books into the new cell. Our body works in a particular way. During each division, a blank page will be ripped off the book. Therefore, the blank pages will be fewer and fewer in the new cells with each division. Until, at some point, there are no more blank pages, then the book can no longer be copied. It means the cell will stop dividing into new cells. Studies show that our cells can only be divided 50 times on average. Because this limit exists, our bodies will age and eventually die. In other words, our life expectancy is determined by the size of the telomeres on the chromosomes. The way our telomeres work makes us wonder, there must be a plan when we were created, and mortality was part of the plan. Why? We will get to this part later. And here is another factor that limits our life expectancy as well, the damage and mutation of genes. Various stimuli could cause the mutation of genes, chemicals, cosmic rays, radiation, virus, or even the duplication of cells. Most of the time, cells with damaged and mutated genes may not function normally, and will die or cause diseases such as cancer. So, these genetic factors have limited our life expectancy. On top of that, another factor that will affect our life expectancy is the frequency of cell division. Although our cells can only divide roughly 50 times in our lives, if our cells divide less frequently, for example, once per 100 years, we can live 5,000 years in theory. But in reality, our cells divide roughly every 2 years. 2 times 50 is 100. That's why people die before or around the age of 100. So what controls the frequency of cell division? It is metabolism. Metabolism happens in the microscopic sense in the cells. You may understand metabolism as eating food, absorbing nutrients, converting the nutrients into energy through breathing, and then functioning. Toxins and damage will accumulate in the cells, so they must divide to replace the old and dying cells. A lower metabolism rate is often correlated with longer life. By looking at the life expectancy statistics of the world, you will notice that in every country, women live longer than men. One of the reasons is the lower metabolism rate. An average woman needs 2,200 kilocalories per day, while an average man needs 2,700 kilocalories per day. So although men have stronger muscles, can run faster, and have more strength, it is at the cost of burning more life energy. We even have some interesting observations on animals too. A faster heartbeat usually means a faster metabolism rate. A mouse's heartbeat rate is 600 times per minute, and it can live about 2 to 3 years. An elephant's heartbeat rate is 20 times per minute, and an elephant can live 60 to 70 years. Blue whale's heartbeat rate is roughly 10 times per minute, and they can live around 100 years. An interesting fact about mammals is that most mammals have approximately 1 billion heartbeats throughout their lifetime. So to most mammals, faster heart rates are usually correlated with a shorter life. But there is one exception in this graph: humans. Our average heart rate is about 75 times per minute. To live over 75 years, we need to have 3 billion heartbeats. This number has far surpassed any other mammals. Even our close relatives, gorillas, have only 1.3 to 1.5 billion heartbeats per life. Why is the human heart unique compared to other mammals? It is a puzzle. Now that we know, humans and animals will eventually die. It begs the question, why do we have to die? Was death part of the equation from the very beginning, or was it a product of evolution later on? Do you know that our evolutionary ancestors, some of the earliest living organisms on Earth, have lived forever? Prokaryotes, such as blue-green algae, or a bacterium, could live eternally. They won't age. When they multiply, the cloned cell is the same as its parent cell. It will not age nor die naturally. It will just keep living and multiplying if conditions are favorable. It doesn't mean bacteria are invincible. They may still starve to death with insufficient food. They may also die when exposed to adverse environments, such as certain chemicals or diseases. They can even be eaten by other protozoans or bacteriophages. Now we see two sides of a coin. Prokaryotes such as bacteria have the potential to live forever by precisely cloning themselves, but that also makes them bear a huge systematic risk. Because they all share the same weakness, eliminating them is relatively easy once the weakness is found. The whole colony could be wiped out altogether due to a lack of robustness. To counter this systematic risk, eukaryotes emerged roughly 1 to 2 billion years later. This organism eventually gave rise to humans and other animals. Unlike the earliest immortal living organisms, humans and animals have genders and limited life expectancy. Why is gender so important? Living organisms used to multiply by cloning themselves. But after gender appeared, living organisms multiplied by sexual reproduction. Although the multiplication process became more complicated, it gained one advantage: descendants will be slightly different from their ancestors. Why? Because the children's genes are a random permutation of their parents' genes. There are numerous possible permutations, so every child will have different genes, except twins. So that's why we look different from our parents and our siblings. As everyone is unique in the genetic sense, we will be less likely to share the same apparent weakness. This diversity enables the entire human race to be more robust against adverse conditions that could wipe us all out. So, the existence of genders makes sense, but why do we have limited life expectancies? Well, think about the mutation and damage of genes. They can be caused by many factors, such as cosmic rays, chemicals, or even cell division. When people live long enough, having mutations and damage to genes is inevitable, and these errors will accumulate over time. Check out this graph. The risk of having cancer significantly increases with age. This is just one example of what mutations could do to people within 100 years. Imagine if they live for more than 100 years. The longer people live, the more severely damaged their genes will be. Eventually, the accumulated problems are so severe that they will put an end to their lives. Another theory is that having limited life expectancy will preserve the healthiness of the human gene pool. In a hypothetical world in which people live long enough, the offspring may meet their ancestors without knowing their relations. If their genes mix, the older genes which contain mutation and damage will be passed along to the new descendants. It pollutes the gene pool of the entire human race. It will only worsen over time. At some point, all our genes will be so corrupted that the whole human race will be at the risk of extinction. However, having limited life expectancy removes this possibility because people will not be able to mix with their ancestors. So you see, not being able to live forever as an individual seems to be a radical yet effective mechanism to preserve the gene pools of the entire human race, which enables mankind, as a whole, to perpetuate. The meaning of death is profound to us. Without the death of the ancestors, there is no healthy offspring. Individuals will die, but mankind as a whole will live on. Our genes are so smart that they have decided to give up eternity on an individual level. Humans are not the only ones who can feel about death. There was a very smart female gorilla named Coco who knew approximately 2,000 words. She could use sign language to communicate with people. Coco also had her own understanding of death. Dr. Penny Patterson, Coco's sign language teacher, once showed a skeleton to her and asked, "Was it alive or dead? What will happen to it?" Coco replied with signs, "Dead, covered up." Then Dr. Patterson asked, "What happens when animals die?" Coco replied, "A comfortable hole." Before that conversation, Dr. Patterson didn't teach Coco about death. Coco might have gained the understanding of death by observations in her daily life when she saw insects or other animals die. Dr. Patterson had also trained another male gorilla named Michael. He knew 600 words. His mother was killed by a local people in the jungle, and Michael never forgot it. He described his scary memory, and expressed his fears about his mother's death with sign language when asked about death. Dr. Patterson felt that gorillas can perceive deaths similarly to humans. And Michael's perception was more straightforward, while Coco's answer was more intuitive and philosophical. Some dogs will sense their death and dig or find a hole before dying. This is similar to what Coco described, a comfortable hole. Many people with near-death experiences also mentioned heading towards a light in a tunnel, which resembles the comfortable hole image Coco described. It's incredible how humans and animals have similar perceptions of death. Maybe the concept of death is already written in all our genes.